Okay, so we're going to do a little introduction to limits today. And I usually like to start to talk about limits looking at a picture because sometimes I think that that's helpful for people to see a picture or a graph. You know, pictures of math are graphs. So let's take a look at some pictures today and see if we can figure out the idea of limits. Now, one thing I want you to remember as we talk about limits is that limits are this weird thing. Limits talk about what's happening right next to a certain value. So what's happening right next to a certain value, not at the value. So this is the weird idea that we're talking about. Okay, so we're talking about things that are happening right next to a certain number, not what's happening at that number. So we're going to be talking about what's happening right next to certain x values on this graph, not really what's happening at that particular x value. So let's say that this is my function. We'll call him f. Okay, so this is my function f. He's this weird, I don't know, I guess it's some kind of piecewise function thing. He's got all these weird parts, okay? So function f, we're going to be talking about him. And let's just talk about the limit for a second. Now, again, in calculus, you'll get a big formal definition, but I think that this is kind of good enough to get your brain to understand and be able to do these limits. So I'm going to be talking about what happens close to a certain value. So let's start with this one. Let's start with 4. Okay. So the way that I would ask the question is I would say, what is the limit? So this is our little notation for limit of f of x as x approaches 4. Okay. So this says, as x approaches 4, this tells me what function I'm talking about. So I happen to be talking about f of x. Sometimes they actually write the function value in there, but since this is a function that I don't have an equation for, I'm just going to write f of x there. And this one says the limit, so this asks me what's happening close to 4. Okay, so this is asking what's happening right next to 4. Okay, so let's take a look. As we Oh, it's me. So let's take a look. So here it is, our value at 4. So this is my x value at 4. Let's go up to where the function is. So that my function value, so hopefully everyone knows that f of x is actually equal to 3. So the evaluation, if you were to evaluate this function, the value would be 3. So f of x is equal to 3 at that moment in time. But we're not interested in what's happening at that moment in time. We're interested in what's happening close to that value when we're talking about limits. So this is what I was talking about. So what I really want to know is what's happening right here and what's happening right here. Now, if I could draw those lines even closer to my particular value, that's actually what I would be talking about. But I'm going to draw them there because we can't see them if I make them closer. So I'm talking about being like infinitely close to this value of 4. So, what's happening at 4.00000000000, an infinite number of O's. Or zeros, right? 0, 0, 0, 1. What's happening right there at 4.0000001? And what's happening at 3.999999999 if you could put an infinite number of 9s? That's what we're actually asking about. That's what this question is asking. What's happening at those values? Not what's happening at 4, but what's happening at those numbers that are really, really close to 4. So if we look at those numbers that are really close to 4, you can see that the output, really close to 4. So, f of, this is supposed to say f of 4. F of, 4.000, an infinite number of O's, right? 1, is about 3, right? It's about 3. And f of 3.9999999, that's also going to be about 3. Isn't it going to be really close to 3? My output's going to be really close to 3. If I'm right here at 3.99999, we're going to be really, really close to 3. So that's what the limit is asking me. So the limit of f of x as we get closer to 4, so as we approach 4 on the x value from both sides, so over here, you see if I'm starting to approach from over here, so I'm starting here and I'm starting to get closer to 4, this output is actually getting closer to 3. And if I start over here and I start to move close to 4, then my outputs are also getting close to 3. So my limit as x approaches 4 is going to be a 3. Okay? So the weird thing is for these continuous functions, well, take a look over here up at, x is equal to 7. So f of 7 is going to be 5, but so is its limit. If I did the limit of f of x as x approaches 7, well, that's also going to be 5, because in order to be continuous, this is one of the ideas of continuity, right? Is that I can, draw it without picking up my pencil. So if right at 7, I'm going to be at 5, well, that means on either side, in order to draw that with one pencil mark, wouldn't I have to be close to 5 here and close to 5 here on either side? So the limit is also going to be 5. So when we're talking about continuous limits, or continuous functions, the limit is going to be the same as whatever the value is of that function at that moment in time. Okay, so these numbers and these numbers are the same for continuous functions. The limit and the actual value at that moment in time are going to be the same. That's for continuous things. And you can see it anywhere on this graph. Let's go over here to this one, right, at -2. So here's the value, f of -2. Oh, sorry, I keep doing that. I mean to write -2. -2 is actually a -1. Well, what values am I close to for the y's when I'm close to -2? Well, they're both close to -1 on either side. So my limit as x approaches -2 of f of x is also -1. And that's going to be true anywhere it's continuous. So any piece on here, any piece on this continuous thing, any continuous piece of the graph, the evaluation value is the same as the limit. Okay? So let's talk about these weird places where it's not continuous. So let's start by looking at maybe an endpoint. Let's look at this endpoint right here. Do you see this guy at f of 0? So let's look at the limit as x approaches 0 of f of x. All right, now we know that f of 0 right here is actually equal to 0. There's a little endpoint there, that's fine. So f of 0 is 0. Now let's take a look as we get close to 0 on either side. Over here I'm having a problem. You can't see because my hand's in the way. But over here I'm having a problem making a little value close to 0. Do you see that? I can't really do it on this side. So what's happening here is as I get close to 0 from over here, there's no function. I'm not getting close to 0. I actually can't get close to 0 on this side, right? I can't put in 0.000000001, right? So everybody knows that this one is asking me, what's happening at 0.0001, right? So negative 0.00001 and at 0.0000001. It's asking me what's happening at these two places. Well, I can be at 0.0000001, and that's close to 0. But on this side, I can't get to negative 0.0001. I can't get right next to 0. So there's no way to actually answer this question. It's not doing anything on that side, which means this limit does not exist. Okay, so sometimes we abbreviate it as does not exist. So this one doesn't have a limit at 0 because it's not doing anything right next to 0. So I can't talk about what I'm doing next to 0 if I'm not even around 0. Okay, so that one is it does not exist. Now that brings us to a different question, like this little hole here. So if we look at this one, f of 1, we would say is actually equal to 3. So if I put in a 1, I'm actually going to get out a 3. Do you see that? Let's look at the limit as x approaches 1 of f of x. Okay. So what I'm going to do is I'm going to look at what's happening right next to 1. So like here and here. So what is this question asking me? Again, what's happening at 1.0000001 and 0.9999999. That's really what I should be thinking about. What's happening at these two values at this moment in time. So I'm imagining that I'm close enough here. Okay, and we all know that this hole, I drew like a big gaping circle, but holes in a graph are actually, they actually have no size because a point has no size, right? So it's a really, really tiny thing. We couldn't even see it. So if we look at this one, f of 1 is actually equal to 3, but we don't care what happens at that moment in time. We're only asking what happens right next to that moment in time. So what happens here and here? Well, both of these are actually getting close to the value of 1. Do you see that? This output would be close to 1, and this output would be close to 1. So the limit as x approaches 1 is actually a 1. Okay? Weird, right? Because we're not asking what happens at that moment in time. Just like right next to me, what's happening. That's what I want to know. So it would be the same if this wasn't here, actually. If we didn't have this point, the limit would still be 1. It doesn't matter what this is. It only matters what's happening here and here. Okay? So if we take a look at this one, hopefully, you can kind of guess that it's the same idea as this one. As we get close to -5, on this side, it's getting close to -3, but on this side, it's not doing that. What's happening? There actually isn't something over here at -5 because this thing has sort of like this asymptote thing happening here. So it's not getting close to a value over there because it's not doing anything over here. So at -5, we would say the limit does not exist again. All right. Now the last weird thing on this graph is that asymptote. So let's take a look at that asymptote. So if we look at this one, so let's say we want to know the limit of f of x as x approaches -6. So what is the at -6? F of -6, I think you would agree that this is a does not exist. It's, nothing, right? It's undefined, right? However you want to talk about it. There's nothing there at -6 because we have that asymptote. So this would be something that has like a x plus 6 on the bottom or something. It's causing that sort of asymptote thing to happen. So what is the limit? Now, in this case, we're getting closer and closer and closer to infinity on this side. And we're getting closer and closer to, nothing on this side. So this is another one that does not exist. Now, the weird thing about this guy is if he had something that looks like this. Let's say this is -6 again. And we do this. And we do this. So technically, the limit here does not exist. So the limit, so we'll call this one g of x. So let's say this is my function of g of x. So my limit of g of x as x approaches -6 is also does not exist. Because for it to be a limit, you have to be approaching a number. And we've already decided that, infinity is not a number. It's an ideal, right? It's a list of numbers. It's a theoretical idea. It's a, what we hope to attain, but it's not a thing that is a reachable, attainable. It's not a number. So in this case, the limit does not exist because it's not actually a number. But we often describe this one, if you said this, as x approaches -6 is equal to infinity, that would be an acceptable answer because we know as mathematicians that there is no limit. The limit can't be infinity. That's not a number. This tells the reader that not only does it not exist because we put the number infinity there, which isn't a number, but also something about the graph. Now I know that the graph is going up in both directions here. Because if I had this one, let's make this -6 again. If it did this, And this one, we could say is that the limit does not exist. Because what's happening here is on this side it's going towards infinity, and on this side it's going towards negative infinity. So in our case, it doesn't exist at all. We can't describe it, as infinity or negative infinity, because it's doing two different things on the ends. And just like this one, it's doing two different things. There was somehow an asymptote here and an endpoint on this side. So in this case, we couldn't describe it as infinity or negative infinity because it wasn't doing the same thing on both sides. So to be a limit, you have to be doing the same thing on both sides. So just like these endpoints, we're doing something on one side but not on the other. So the limits do not exist there. Here, we're doing the same thing on both sides of the point. We're both getting close to 1, so it does exist there, even though it's discontinuous at that moment in time. So to wrap up, we'll talk about one-sided limits in the next video, actually, so stay tuned, right? That's going to be exciting. But so to sum up, limits exist when you're doing the same thing on both sides of a value. So if I'm getting close to the same value on both sides of a number, then you have a limit. So here we have a limit. We're both getting close to 1. Here we have a limit. We're both getting close to 5. And whenever you have a continuous piece of a function, then that limit is going to be the exact same thing as plugging in the number. And we actually say we can solve those limits when it's a continuous function by direct substitution, because we just put those numbers in and figure out what the value is. So if you know the function is continuous where they're asking you, then all you have to do is plug in the number. Limits do not exist when you're not doing the same thing on both sides. So here you're getting close to -1, but over here you're not doing anything, so not a limit. Here you're getting close to infinity, and here you're not doing anything, so not a limit. Limits do not exist when you're getting close to infinity or negative infinity. So even, like I said, if you have this case where they're both going towards infinity, doesn't exist. But oftentimes, if they're doing the same thing, they're going to describe the answer as infinity or negative infinity. But this one, since they're not doing the same thing, you can't describe the answer that way either. Okay? And just like one more thing, which maybe I didn't put on the graph, something like this. Oh, that's not what I meant. Let me draw it a little better. I'm so goofy sometimes. Yeah, this is an easier one to look at. So if this is, I don't know, q of x, I'm running out of letters here. So let's say the limit of q of x as x approaches 0. Well, over here, I'm getting close to the value of 1, but over here I'm getting close to the value of 0. So do you see how it's not doing the same thing on both sides? Over here, it's getting close to 1, and over here, it's getting close to 0. So this one would be a does not exist. So to be a limit, you have to be doing the same thing on both sides. Okay? All right. Now, again, there are things that we call one-sided limits, and we will talk about those. Make sure you check out that video so you know what a one-sided limit is about. But you probably have a guess. All right? So hopefully that gives you an idea of what we're talking about when we talk about limits.